All right, we are into this next question. It says, how many oxygen atoms are in 2 grams of the acetylsalicylic acid? Same chemical we've been working with, but now we found moles, but they want to know about oxygen atoms. And so the key thing in this problem that you really need to be looking at is this oxygen atoms. Oxygen atoms are a problem because when we look at the formula, we're going to see that the entire formula is not made of oxygen atoms. So it's going to make for a bit of a trickier problem than we maybe are used to. So let's take a look. And so we're interested in the oxygen atoms. So we want to know how many oxygen atoms do we have in 2 grams of our acetylsalicylic acid. Okay, and so when you're looking at this question, I'm going to use the notes here. That's a difficulty because if you look at the formula, which I'll blow up right here, that's not all oxygen. Just some of it's oxygen. Okay, so C9H8O4, not all oxygen. So let's go ahead and jot that down. C9H8O4. Okay, so let's do some terminology. So first of all, this is what we would call, that's a molecule. So that's a group of chemicals. And in that molecule, in that group of chemicals, 4 of the atoms happen to be oxygen. Not all of them, but 4 of them. So we're going to convert in a very, we're going to have a plan here. And so our plan is going to be this. We are going to go from what they gave us, grams. We're going to convert that into moles because if you want to go to atoms, molecules, things like that, you have to go to moles. We're then going to go into the big pieces, which are going to be the molecules. So we're going to go to the molecules. And then we're going to slide from the molecules into the specifically the oxygen atoms. So you guys are going to get this big, long conversion factor, but it's manageable. But what we want to understand is that there is a pattern here, and we can't skip anything. So this is where we start. Then always have to go to moles, then particles, and then now the more specific one. Okay, so let's see if we can do that. Which, well, I mean, I know we can do it. So let's just do it. Okay, so we know we always write down the number. They only gave us one number. They gave us the 2. Make sure it is a 2.0. It is. They gave us the 2.0 grams. And I'm going to write this kind of small because I might run out of space on this one. So C9H8O4. So that's what we start with, grams of that. And so what we're going to do first of all is there's a conversion factor. So right away we're thinking to ourselves, well, what do I have? I have grams. I want to get rid of the grams. So I'm going to put them down here on the bottom of the conversion factor every time. I'm not going to, one needs the highlighter though, one needs the pen. So every time we're going to do that. Okay, so what goes on top? Well, what we want? Well, we want oxygen atoms, but as you can see, this one's more complicated, and I can't go directly to what I want. So that I'm going to go to moles. And so here's a good place to do a little bit of learning. Every conversion factor is probably going to have the mole in it somewhere. So if you don't have moles somewhere, you're going to need it. So this is a multi-step conversion factor because I can't do it in one step because every step is going to have the mole in it. And so there's no mole here. So mole is going to end up on top right there because see, I didn't have a mole. It's going to end up on top. So now that I have that done, let's go ahead and set up the next conversion factor. Well, Doesn't look as clean as I'd like, so let's try that again. Look at this. Okay, so if you have moles on top, you now need to get rid of them. So now moles are going to go on the bottom. And then the unit that you want is going to go on top. So we talked about this already. We're going to do it in this order. So we're going to go to, and this gets a little confusing here. I'm going to go ahead and erase this, I think. Give me a little more. Whoops. I'm going to erase this. Give me a little more space right here. Yeah, there we go. Okay. This is going to be the C9H8O4. We're going to convert into those molecules, okay? So we're going to convert into the molecules. Right? So that's where we're going to go. So let me clean that up a bit. Don't like the looks of that real well. You guys will find out that I basically write in all capital letters. So when I try to do lowercase, it starts to get a little squirrely. So let's go ahead and clean this up a bit. Get rid of that and extend that line. Okay. Now we're where we want to be. Okay, here we go. Now we're good to go. All right. And then the last one is going to be where we want to go, which is going to be those atoms on top. And those are specifically going to be oxygen atoms. And then on the bottom, we're going to put the word molecule. I'm going to kind of run out of space. So I'm going to, actually, let me just abbreviate that. I was going to go MOLEC. There's your molecule down there. Okay, let's put in numbers. Let's go back. Okay, so we start with grams. How do we get from grams to moles? Well, we know that the mole is normally going to get the 1. And we also know that grams, where do they come from? Those are going to come from the periodic table, right? So periodic table. So we're going to look that up. Well, we've already done that, right? We've done that like a whole bunch of times. And we found over and over that the chemical we're working with weighs 180.17. So we're going to put that right here, 180.17. Okay. So then what this does, if you're canceling units, which you guys really should cancel units, if you have a unit on top and a unit on bottom, then they are going to cancel. So see, look, the grams cancel, and that's a good thing. Now look, over here, the moles are going to cancel, which is what we want, but we got to figure out our numbers. Well, the mole is, as I told you guys, is going to normally get a 1. So it gets a 1. Molecules, though, get what number? It's the Avogadro's number. So remember, if you don't have grams or liters, if you have anything else, you're going to use the 6.02 times 10 to the 23rd. So grams or liters have their own thing. Periodic table for grams, 22.4 for liters, but everything else gets the 6.0 times 10 to the 23rd. So if you are struggling and it says ions, molecules, atoms, whatever, it's probably going to be the Avogadro's number, 6.02 times 10 to the 23rd. Okay. Now this is the kind of the tricky part. This is kind of the conceptual part. So this up here, that is a molecule, one molecule. Inside the molecule, you have 4 atoms. So you get 4 oxygen atoms for every 1 molecule. And so that is what we're putting down over here is this item. 4 oxygen atoms for every 1 molecule. And you may be like, well, where is he getting that? Like, I don't understand. Well, it's right here. See that? That's 4 oxygen atoms inside this 1 molecule. So it's 4 oxygen atoms for every 1 molecule. So now we can do some canceling. Moles are on top. and on bottom, molecules on top and on bottom, and look right there, atoms are what we're left with. Well, that's what they wanted. Okay, so how do we do this in our calculator? Well, the way we do this in our calculator is we plug in the starting value, the 2.0. This is on the bottom, so we divide. So 2.0 divided by 180.17. So let's do that together. 2.0 divided by 180.17. Now hit enter. Don't want to just stick it on your calculator. You want to hit enter. Okay. Now we're going to multiply by 6.02 times 10 to the 23rd. Okay. If you're going to use carets, you need to put it in parentheses. If you're going to use the double E button, you don't have to. But if you're going to hit times 10 caret 2, 3, then you need to put things in parentheses. So what I'm saying is if you're entering stuff in your calculator like this, so let me get the pen, not the highlighter. If you're doing stuff like this, 6.02 times 10 caret 2, 3, you've got to put your stuff in parentheses, and you've got to get used to that or you're going to get answers wrong. If you're doing it like this, 6.02, and then you're doing, then you're using your exponential function, then you're fine. So the exponential function is a button that looks like this on your calculator, double E, and then you would plug in 2, 3. So see the double E button, what that means is it means times and 10. So it takes the place of that. So that's really up to you. I use the double E just because it's a little bit easier. But anyway, so 2 divided by 180.17 times 6.02 times 10 to the 23rd. Hit enter. Now, we don't need to worry about the ones. They don't do anything mathematically. Multiply by 4. So you can see I'm just walking myself across. So we just multiplied there. Now we're multiplying there. Multiply by 4. And you should get a fairly large number. I mean, they are atoms, right? Atoms are itsy bitsy things. We should have a whole bunch of them, and we do. We end up with 2.6730311026 times 10 to the 22nd. That's too many sig figs. We only get to keep 2 sig figs because these are all conversion factors, so they don't use sig figs. So just the first number. So I'm going to keep 2 of my numbers. So I'm going to go 2.7. See, I rounded times 10 to the 22nd. That 10 to the 22nd does not affect sig figs, and you have to have it because it's part of the number. And so that would be oxygen atoms. Okay, so challenging problem, but you guys can go through it and manage it. And like I said, if you're struggling with anything with this format, you can always go back and relook at something. Okay, so we're going to have you guys take a look at the next one, which is you've got molecules of 2 things, and they want to know how many hydrogen atoms do we have total. So the key here is to take your molecules and turn them into atoms for